Okay, so statistics. What's statistics all about? I'm sure you've heard of it. I'm sure you're like, I don't know, it's something with numbers, lots of numbers. And if that's what you were thinking, you are right. We are gonna interpret, right? So statistics, if you look here, is the collection and analysis of data, right? So just having a bunch of numbers, just asking a bunch of questions and not really doing anything with it is pointless, right? But that's also important to know what is the data telling me, because you can make wrong conclusions if you don't know how to read it properly. It aims to interpret that data, what data is trying to tell us, right? So interpret, right, is you're trying to read and see like what is data trying to tell us. And here are some of the topics that we're going to cover. So at the center, right, at the very center of this all, right, you have data, right? You're going to collect, and I just give you some examples, right? It could be people's heights, their scores, morning, the IQ, number of items, etc. Like data is being collected all the time. Hours of sleep you get, hours you spend on your phones, we spend on our phones, right? That's all like data is collected all the time, right? And from it, we will be able to find the measures of central tendency, right? MCTs, I call them. That's the mean, the median, and the mode, right? We will look at dispersion, right? A range, like how spread out. Dispersion, right? How spread out is the data, right? How does the data deviate from the mean? Okay, so you're going to look at that as well. And then we'll also look at standard deviation, right? Measures how spread out the data is, right? Tells us how the data deviates from the mean. Deviates is like varies, right? You can put varies under deviates, right? We're also going to visually represent our data. We're going to make some graphs, right, to be able to see clearly what's happening here. Because just looking at a bunch of numbers and not organizing them is very hard to tell what's happening. And then to sum it all, like this is going to be probably if you take stats in college or university, you will look at normal distribution, which is a bell curve. So just try to make a straight line like this. That's not very straight, is it? There, try it again. And here's the way we're gonna do this. You go you make a point somewhere up top, and just watch me do this first. It's like a hat, like a bell actually. Right? It goes like this. And you go back to that center, and it's symmetric, and that goes like this. Okay. And in the middle, right down the middle, you make a line, and this is what we call our mean, right? The average, like most of our data, most of the data points are going to cluster around the mean, around the average, right? And so I want you to think of bell curve as well. That is going to be where we're headed, guys, normal distribution. It turns out that a lot of human attributes or a lot of things that we collect about humans resembles a bell curve. Average height, right? There's this average height that we can calculate, and most people will be around that height. And then there's going to be me. I'm going to be somewhere over here, right? But not a lot of people are as tall as me, right? And on the other hand, right, there's shorter people, but we have this average height for, it depends on the country, right? but there's this average you can calculate, and most data will cluster around it. And then as you go to either extreme, it lessens. Same with you see geese all the time now, right? There's the one date where most of them arrive. Some arrive super early, some arrive very late, but there's the date you can kind of find that average date where most geese arrive in the spring, right? Same thing. So a lot of normal distribution in life in nature, especially when it comes to human qualities, human attributes. Okay, let's keep going. This is just an intro. So now you know where we're headed. What can you expect? So let's start with the MCTs. Remember, it stands for measures of central tendency. That's what that means. And you have the mean, median, and mode are the three most common ones. Okay. So if you have your highlighter ready, I will highlight a bunch of things. Measures of central tendency is the number around which where data clusters. We're trying to find a center. We're trying to find where does the data tend to go, right? Where's the tendency? In mathematics, there are several different measures of central tendency. The most common is your mean, right? Usually called average in everyday language. We say when it's mean, we actually are referring to average. And so mean here gets this symbol, right? It gets the X with the bar on top, or it gets mu, which is the Greek letter for it. So most of the time I use the X bar, but some textbooks, or actually almost every textbook, uses that Greek letter as well. Okay. The arithmetic mean, this is the official name of it. The arithmetic mean is denoted by the symbol, right? You've got the symbol X bar found by adding all the values in the data set and then dividing it by the sum of number of values in the set. Make sure you include units, please. And you can round this one. I will make a note here, round to 2 decimals. Right? So sometimes it will be weird, like it'll be like, what's the average number of children per family? 1.5. It's like, what? 1.5? It's to measure, because it could be that another country has 1.6 on average, right? It's still telling us that that other country has more children per family, right? So we kind of use it to compare, right? Obviously, you can't have 1.5 children, but anyways, that we keep it that way. So this is the official way to write the formula for average. It would be the sum. That is a symbol for sum, adding everything up. Sum of all values divided by the number of values. That is the official. They never taught you that one in junior high, did they? But that's really where it's at, right? So this is just saying sum of all values and number of values. So there's your formula, your official formula, and we will refer to that from time to time. Median, what is the median? This is very important. It's the middle value of the data set. It's most easily found when the numbers are listed in ascending or descending order. It's basically saying arrange them, either from smallest to greatest or greatest to smallest, but you want to arrange your data set. Our calculator is going to be awesome for that. You won't have to do it by hand. But this is important. I'm going to use a different color for this one. When I ask you, what does it tell us, right? It literally tells you half of the values are above and half of them are below, right? So if the median income for Winnipeg is $45,000. It's telling us that half of the families make less than $45,000 and half of the families make more. It could be that someone makes $1 million. We don't know, but we know that half are above, half are below, right? If there's an even number of values in the data set, the median is the average or the mean of the two middle numbers. Again, make sure you include units. So for example, let's say you have a set. I'm going to arrange it already. 2, 3, 5, 11, 16. Right? This is an odd. Right? Odd, you have 5 values. In this case, it's very easy. This is your median. Right? I should have left more space. Apologize. The median would be this one, right? So you have 2 above and 2 below, perfect. So whenever you have an odd set, let me just try to focus one more time. When you have an odd set, then that's what you do, okay? When you have an even set, so let's try this again, 2, 3, 5, 11, 16, and 21. Right? This is even, 6 values. It says 6 values there, trust me. In that case, you need to take the average of these two. The median is going to come out of these two values. And I don't know, like, I know that they should teach this in not elementary, but in junior high, but you forget sometimes, right? So basically what you do is you go 5 plus 11, like you add that up, always make sure you put that in brackets and then divide it by 2. And so that would be 16 divided by 2, which is 8. And I'm just going to tack on units there to get used to that. In this case, we don't know what they are. Okay. So technically, the median in this case is not a data point, right? It's not one of the numbers, but we know that half of the values are above 8 and half are below 8, right? So it would technically go somewhere in here. Let's keep going. The calculator is going to do this for us as well, but I still would want you to, if the data set is small enough, I would want you to do this by hand. Okay. Mode is the number that occurs most often. Let's just go, I'm going to highlight median because it's important. Mode occurs most often, right? That's for mode. It's the most popular one. Let's put just all of these in. These are called our MCTs, right? Don't forget that. If I ask you, hey, what are the MCTs? It's mean, median, and mode. They're not always not all of them are the best, right? Sometimes the mean can be affected by outliers. What are outliers? We'll get to it. The mode can be affected, like if there's a lot of values that are way high up there or low, it's not going to be right in the middle, right? So median is usually the one that's used most often to find the middle, right? No mode if each number appears the same number of times. So here we go. So if you have like a 3, 3, 4, 4, 5, 5, 11, 11, let's say, there's no mode. No mode. So you could say, if I ever say, hey, what's the mode? You say not applicable, okay? This is a common error. Mode, a lot of students would say, well, it's 0. Mode is 0 because there is no mode. That's incorrect because then you're telling me 0 is the one that occurs most often. So this is an error that you don't want to make, okay? One mode if one number occurs most often than the others. So 2, 2, 3, 3. Let's say you have 3 5s, 6, 10, 14, let's say. And there's your mode right there. You can tell that 5 occurs most often than any of the other ones. So their mode would be 5 units. So this could be, right, minutes it took you to walk to school. So you would say most of the time it was 5 minutes, right? And I have to reiterate, these are all arranged. When you arrange things, median and mode are easily found, right? So both of these are easily found when things are arranged. So I will encourage you to do that. And your calculator is going to be great for it. A number of modes if 2 or more numbers occur at the same number of times. And this is the greatest number of times an entry occurs in the data set. Well, what is that saying, right? So let's try this out. So you scan the arranged data, and you see that we have 3 1s here, and we have 3 13s there. And they occur more often than the other ones, because you do have the 17 that shows up twice, but it's out. It's no longer competing for the top spot, right? So here, mode would be 1, and as well as 13 units. Okay. Although the mode is referred to as a measure of central tendency, right? So I would say mode is a measure of central tendency, does not necessarily lie towards the center. In fact, I'll tell you this, if the mode appears to not be very, very centered, it usually means that the data is skewed. It's not normally distributed. It doesn't make a nice bell curve. Things tend to be more on either side of the spectrum, right? So giving you a little bit of a foreshadow there. The mode is used in different situations than the mean or the median. For example, a store owner could use the mode to find out which t-shirt is most popular, right? That's when it's probably a good measure to use, right? Like, hey, I need to place an order, which t-shirt size or style, right, is most often sold, right? And use the information to decide how many t-shirts to order in the future. Mean and median wouldn't help the store owner make this decision, right? Because you might get, shoe size. You do the average, like, oh, order size 6.83. It's like, oh, doesn't make sense, right? You would actually want to say, what is it? Is it size 7, 8, 9? What is it? So you would use the mode in that case to help you out. Next is range. This is not an MCT, guys, okay? But range and outliers need to be talked about as well. This is, range is calculated. You just subtract the smallest from the largest. It measures, let's use a different, measures dispersion. It tells you how spread out the data is. The bigger your range, right? The bigger the range, the more spread out your data will be. Okay, that's just a fact, right? The bigger that number. So I would say this, range is max minus the min, right? So when you subtract, like let's say I teach a particular class, right? I have a student that scored 90%, I have a student that scored 10%. 90 minus 10, 80% range. I teach another class, let's say there's an 80 highest score, 50 is the lowest score. The difference there is 30% only. So my data on that other class is going to be clustered a bit more than the one where I have the 90 and the 10, right? So keep that in mind. Let's keep going. This is where it gets a little, this is probably new to you, okay? And I apologize, I'm gonna overload you with some information today, so be warned. But it's necessary, right? I need to first set it up before we can do some math here. Standard deviation, very important concept. Right? Sometimes I just call it SD. Right? Standard deviation or sigma. It is that's the symbol for it. It's like a zero with a little tail on top. That's basically how I do it. Watch this. Measures dispersion or variation within data points. Okay. And here is, I'm going to use a different color because I like the contrast. You don't have to, but here it is. Standard deviation is the average distance from the mean, right, of all data points in a set. Okay. And this can be calculated, right? This can be calculated. And it has the same units as the rest of the data set. You know what? I don't have this in my original, but I'm going to do this because some students need a little visual here. I'm a visual learner too, but maybe don't write this down. Just maybe try to pay attention. So yeah, I'm going to use scrap paper because it's not going to work if I. So let's say I have this number line. I have a number line. And as I'm looking at the test scores, I'm plotting them on here. So if let's say I somehow calculate that the average is 75%. This is the average, right? And I have scores all over the place here. Some doubles, right? Maybe some marks that are occurring more often, but I have scores all over the place. Standard deviation is going to calculate the average distance of every single point to the mean. So the greater your standard deviation, the greater that number we calculate, the more spread out this is going to, it's going to tell us that this thing is spread out. If I look at another class, and let's say that average for that class is 60%. You're like, whoa, it's a lower average, right? But I am actually more interested in seeing how spread out is the data, right? So is this going to be a case where if I put these points down, I notice, hey, wait a minute, most students are scoring close to 60. I'm just going to make up a number. Let's say we calculate the standard deviation for each, right? Let's say we calculated. This number should be greater. It could be 10%. We would have to calculate that. But what I know for sure in looking at the distribution here, the standard deviation of this set should be much lower. Probably, I don't know, I'm just making this up, probably 4%. So the standard deviation is the average distance of every single point with respect to the mean. All right? So let's now look at these visuals that I have here for you. Sorry, I did this with my mouse. I couldn't find something to make it nice and smooth, but I tried my best, right? So we're going to compare a lower standard deviation and a higher standard deviation. And I'm going to zoom out for this, okay? But a low standard deviation, you see that the graph it's steeper, it's closer to the mean, right? When the standard deviation is high, we have a flatter curve. And you can imagine you can just imagine that here you're going to have just put a bunch of points that kind of stack up here. Like if I could plot the data, it would fall in there. And you have a lot of repetition. That's why it's stacking up like that. Versus a higher standard deviation, you're going to have things spread out more, right? So you can just, you still have some doubles maybe, right? But that has spread out, and you might even have some outliers. Okay. So let me just tell you this, a high standard deviation when it comes to teaching is bad. If you're a teacher and you calculate your standard deviation, you have things all over the place. There's no consistency. So maybe my teaching wasn't that great because some students nailed it, but others didn't, and there's everything in between. As a teacher, you want this. Because if you see this, you're like, okay, whatever I was teaching it consistently. Maybe I just needed to emphasize some more to bring the average up, like to move this whole curve up along the x-axis, right? That could be a totally different story, but if you're just looking at standard deviation, it's the dispersion. So let's highlight a few more things here. If you have a lower standard deviation, the range will be low as well. The range will be low as well. Just look at the min and the max, right? They're closer together here. Let's do this. Max minus min, right? That's how we find the range, right? So the range will be small as well compared to the one below here. The range is going to be more, it's going to be a bigger number. So I'm going to use a different highlighter for the range will be greater. So here, range is low, range is greater, right? So there's a relationship between the standard deviation and the range. Remember that. There's a direct relationship between them. We can then also say, so these are all bullets that basically are closely tied to the lower standard deviation. Data is clustered around the mean. That's very important, right? We would also say that data is consistent. There are few or no outliers, right? Few or no outliers. There will be a steeper curve. That's important. So if you can wrap your head around this, if you can manage to add this to your study sheet, I think you're going to benefit greatly, because this is basically one of the biggest concepts in this whole unit, is understanding how standard deviation is tied to these other components. Okay. If you have a higher standard deviation, the range will be greater. The data will be spread out, right? So data is scattered further from the mean. It's less consistent, may have multiple outliers, and you'll have a flatter curve. COVID, the whole reason with all the restrictions is we wanted this to happen. We wanted to, remember, flatten the curve. Does that ring a bell? They didn't want all people to get sick at around the same time, because then it would overwhelm the system. So when it comes to the health system, they wanted a spread, right? They wanted the standard deviation to be high. That way we could cope with the patients and the cases a bit better, right? So it's not always that we want this every single time, but most of the time, this is what we're after. Okay, let's keep going. This is where it gets to the calculator part, okay? Using the graphing calculator to find the MCTs. I used to do a lot by hand in this unit, but I realized we're doing applied for a reason. We want to deal with lots of numbers. So sometimes I'll give you 30, 40, 50 values. Good luck doing that by hand. I find it's pointless. Because once you do stats in university, you do lots of values at the same time, right? Or anywhere else. If you work for a company, you might be able to apply this as well. If you're into business, you do you analyze stats all the time, right? Like how are we doing? How are our sales? When are we selling most, right? What should we do to change that, like to increase our sales? It's all data driven, right? So here we go. These are the steps, and so right now it might not make sense to you, but basically what I want you to do is highlight this whole box, right? I think, after a while, you're going to be champs and you're not going to even need these steps. But I always want you to be able to go back and see, hey, this is how you do it. So we will enter data points into L1. You know where that is, thanks to quadratics, right? You sort the data set. I'm going to show you how to do that in a bit. But really, we go stat, and then we go sort in ascending order. There's sort A and sort D. I just use sort A all the time. Calculate the mean, standard deviation, and median using stat calc, one variable stats, and then you should see this. And here's where I want you to highlight things. The most important pieces would be this one here. This one, that's your average. This is your average. X bar, right? Then I want you to highlight this one. That is your standard deviation. And I'm just going to use a different color because I wanted to. This tells you the number of values. Number of values in set. And I can't stress enough, check that number. Because sometimes you're supposed to have 50 and you see 49 there. You didn't type all of them in. You missed one, right? So I always check do I actually have as many as I should be having. Hey, by the way, this continues. You're going to have to scroll down on your calculator to see this part. But basically, I want you to highlight this. That is your median. Hey, we don't have to do that by hand. Way to go, right? That is your median. And that's all I want you to get right off the bat. However, to find the range, we subtract max x minus min x from calculator. So I'm going to use pink maybe just to highlight these guys here. This is the lowest value and this is the highest value in the set. And those are the ones you're going to use here to figure out your range. Okay, so in this particular case, your range would be 9 minus, watch this, double negatives. So max minus min. Min happens to be a negative, right? So that really just turns into a positive there, right? So it's really 9 plus 12, which is 21 units. We have no idea what these units are. Is it degrees Celsius? Is it, right? What is it? We don't know. Right now, we're just going to put units down. Okay. Determine the mode by looking at L1, which is now sorted. I'll show you how to do that. So you're just going to have to look for it. The calculator doesn't give you that right up front. So let's give this a try. That's why I put the chart right underneath this. Let's type in Toronto's, these are the daily highs over a 12-day period during the month of April in 2 cities in Canada. So there's Toronto, and there's Winnipeg. So let's type in Toronto into L1 for now. That's all we're gonna do. Clear whatever is in there right now. Remember how to do that? Remember how to clear? You got to go to the top, hit clear, enter, right? How do you get here again? Stat, edit. It's been a while, right? 5, enter, 5, enter, 8, enter, 9. And can I just say something here? You guys are like pros at texting like super fast. You remember the cutting in when you paint? You cut in. This is where you cut in, you take your time, right? Everything else after, so it should be pretty easy, right? But I'm just gonna check one more time. 10, 9, 3, 12, 7, 9, 0, 5, 9, 8, 5, 5. Okay, so I check, and I also, if you go to the, we can do that later. So I have this into L1 now. What is the second step? I'm asking you to go stat and go down. Instead of edit, you go sort A, sort in ascending order. Hit enter. Go second 1. You got to tell it which row, which column do you want me to sort. L1 is what I feed it. I hit enter and it says done, right? Go back to stat, edit. It's now arranged in ascending order. Isn't that nice, right? Do you see your mode? Let's get the mode. We don't have to do it in order, right? So 1, 2, 3, 3 5s and 3 9s. See that? 3 5s and 3 9s. So those are my modes here. We're good with this? We're following? Okay, I'm not going too fast. Okay, let's leave the mode for now. Let's do the calculation, which is calculating the mean median mode. So how do we do that? We press stat, and then you got to go sideways, arrow sideways to calculate. See, if you go sideways to calculate, you pick one variable stats, which is the first one. We never ever use 2 variable stats in this course, okay? 1 variable stats, that's it. Go hit enter. And I like you to feed it the column you want it to calculate. So I'm going to go second 1. So you're telling 1 variable stats to go and perform calculations based on what's in L1, because I'm going to use different columns at times, all right? Hit enter. And there's our average for Toronto. So let's go down here. I don't need you to show me keystrokes because I know that there's no other way to get this. So we're just going to go X bar is, oh, wait. I'm going to call this Toronto first, and I'm going to do Winnipeg on the other side. So Toronto, the average temperature is 6.83 degrees Celsius. My median, you just scroll down. If you look at your calculator, oh, by the way, let's check. There's 12 values, which is what we wanted. Let's go scroll down until you see median right there. Scroll down right until you see median. That's 7.5 degrees Celsius. And the mode or modes, right? That one you need to arrange, right? So arrange data, right? We go sort A L1 for this one. I'm just going to put this in like a little bubble for mode, right? So we're going to go to stat, edit, back to our cells, right? And we already did this, so it's 5 degrees Celsius and 9 degrees Celsius. So in this case, we have multiple modes here. Let's figure out the range. To figure out the range, I'm jumping a little bit all over the place here. I apologize. I'm going to quit this screen, go back to my main screen, and it's gone. Everything is gone that you did. So I just scroll back up and just execute the program again. Enter, enter. And so for the range, you're going to use the max and the min, right? So you're going to go 12 minus 0. 12 minus 0. That's an easy one, right? So there's a range of 12 degrees in Toronto, the month of April, for those 12 days. And what else is it asking me for? Standard deviation. No. Let's write down the standard deviation. I didn't ask you for it, but we'll do this anyways. Standard deviation. Do you know which one it would be? Based on, this is your mean, and this one, the sigma lowercase, is your standard deviation. Let's just write that down. 3.21 degrees Celsius. Let's go standard deviation next to it because you're still learning how to deal with that. Do you think Winnipeg's standard deviation will be bigger or smaller based on what you know about standard deviation right now? Standard deviation tells you how far from the average all the points are, on average. Winnipeg is probably going to be a little bit more spread out, wouldn't you think? Our temperatures are crazy, right? You should suspect it to be bigger, right? Because it's a bigger average distance from your average. Mr. Erickson, just keep going. Stop talking. I just want to write stuff down. I'll think about it later, okay? No problem. I'm on it. Okay? So let's focus on Winnipeg right now. I don't want you to erase what's in L1. So let's put next to this saying we put all of these points for Toronto into L1. And we're going to put all the points for Winnipeg into L2. I'd like you to be able to compare data. I'd like you to look at different athletes. Like there's going to be a basketball one, 5 different athletes, the points they scored over 10 games. L1, L2, L3, L4. Like just put them all into different columns and use it, right? So I'm going to redo this. So I'm going to go stat, calc, one variable stats. Oh, I haven't done the, I'm ahead of myself, guys, sorry. What do I need to do first? Put these into L2, right? So let's do that. Stat, edit. I'm going to go to L2, 6, 1, 3, 0, negative 1. Oh, that's a negative, right? 2, negative 7, negative 5, 4, negative 12, 9, 6. I don't know what year I took this from, but probably fairly recent. So you have 12. Let's go ahead and perform our calculations now. Stat, calc, one variable stat, second 2 for L2. But Mr. Erickson, you didn't organize it. You didn't arrange it. You don't have to yet. You technically only have to do it just before you find your mode. Okay? So 0.5, watch this. No surprises there, right? We were not surprised that Winnipeg is colder than Toronto. You shouldn't be, at least. Then we find our median. Median temperature is 1.5 degrees Celsius. So half of the time it's colder than 1.5, and half of the days it was warmer, right? And so then we have mode. I'm going to arrange it before I do that. let's just also, the next is range. Watch this. Before I clear the screen, I'm going to figure out the range as well. Range is max, which is 9, minus negative 12. Oh, that's where the 21 came up from up there. Anyways. This is positive, right? So this is really 9 plus 12. So there's a range of 21 degrees Celsius, right? So from the lowest to the highest, there's a 21 degree difference. And that tells you, okay, the data is spread out way more than Toronto, right? Standard deviation, let's write that down as well. It's 5.77 degrees Celsius. 5.77 degrees Celsius. Let's compare that to Toronto, right? We did expect this, right? Bigger range, bigger standard deviation, directly related. Let's find our mode now. Stat, sort. I'm going to sort L2. Then I'm going to go to L2. You already found it, didn't you? Is there a mode? Yeah, 6 is it, right? I find 2 6s there, so 6 degrees Celsius. There we go. Now we're going to use this information and talk about it in statistical terms. You can clearly tell that on average, Toronto is warmer than Winnipeg, right? Even looking at the median, you can tell that it's warmer. Mode would be fairly similar, but the range, like, okay, this is much bigger than there. I expected standard deviation to be bigger as well. Let's go. 5. Line plots. I need to wrap this up here. Okay, line plots. This is where your calculator is going to be such a big help. Okay, creating a line plot, that's very important. You need to know how to do this as early as tomorrow, Monday, right? I will do line plots with you, and you need to label mean, median, and mode on it. Some guidelines. Use the min and the max to determine the scale. Add labels and units. Place data points on the line. Stack if there are multiple entries. We stack them. You can put X's or dots. I like dots, right? Label the location of the MCTs. Range is not an MCT, remember that. Label your MCTs. So we'll do that. And because I want them to match, I use the same starting point of negative 16 degrees. But for Toronto, the min was 0 and the max was 12. For Winnipeg, the min was negative 12 and the max was plus 9. And that's just to help you, to guide you. How high do I need to go? I need to make sure I have up to 12, right? For Toronto, up to 9 for Winnipeg. So I'm going to go up by 3s. So this is going to be negative 13, negative 10, negative 7, negative 4, negative 1. From negative 1, if you add 3, that would be 2, right? 5, 8, 11, 14. Direction could I have gone up by 2s? Yes, you could have, but then you would have run out of runway, and then you would have had to add a bit of line here maybe. That's fine with me. So you make sure you have arrowheads when you're done. I'm going to highlight that as well. Okay. And you have to have Toronto. I already did that for you, but somewhere in there, tell me what units This is in minutes, centimeters, dollars, you name it. Let's do the same thing for Winnipeg. Same scale. So just copy basically what you have on top. And this is going to be in degrees Celsius as well. No surprises there. And now grab your calculator. Okay, so grab your calculator, go to the cells, and because it's a range, it makes it a lot easier to plot these. So 0 for Toronto, your first one is going to be at 0, which is right about there. Then I just scroll down. 3 is right about there. 5 is here. I have 3 5s, so I stack them like this. It's easy to see that that's your mode, right? And then I have a 7, which is somewhere in there. I have an 8. I have 3 9s. I have a 10. I have a 12. And that's about it. Let's just check. 2, 4, 6, 8, 10, 12 dots. Should have 12 dots. I do count. I do random checks when you do these, right? So let's see how Winnipeg compares. Something tells me Winnipeg is not going to have those stacks, right? It's going to be a little bit more spread out, which is what we expect. Let's go through L2 now. So I have L2 ready to go here. And I'm going from the lowest, which is negative 12. Negative 12 is right about there. Negative 7 is right there. Negative 5. Negative 1. 0. 1. 2. 3. 4. 6 and 6. 9. That's it. Can you tell that it's spread out? Can definitely tell it's a bit more spread out. Let's label the MCTs. So for this one, I have to peek once. Oh no, I have it here. The mean is 6.83, so somewhere in here. So you put an arrow and you say that the average is 6.83 degrees Celsius. These are our modes. Five and 9 degrees Celsius. And the median was 7. Let me just check. 7.5. So somewhere in here. That's okay. Just median like that. Median. So you label all the MCTs where they are on that bar. I'm okay if you don't write down the number, just say this is approximately where it is. And then same for Winnipeg. Winnipeg was 0 point something, right? For 0.5. So the average is about there. The median was, what is it, 1? 1.5. So the median is right about there. And this is the mode here. So you can tell that Winnipeg is not lined up as well as Toronto, right? Let's just make an observation here. Range, I'm just going to have that on the side. Range was 12 degrees. Standard deviation, 3.21 degrees Celsius. I'm putting that in a box here on the side. For Winnipeg, it was 21 degrees Celsius. Standard deviation is 5.77 degrees Celsius. Lower standard deviation, data is more clustered around the mean. It's going to be a steeper curve, right? Versus a higher standard deviation, more spread out, inconsistency, and it's a flatter curve. So that's what we're going to talk about in this section below here and see, and that'll be it for today. That's it. I think then your brains are going to be overloaded, right? So Toronto, describe data sets for each city using statistical reasoning. You can use the mean, the range, and the standard deviation. So for Toronto, a greater mean indicates that temperatures are warmer or higher than Winnipeg. On average, I should say. On average. The range and standard deviation are lower, which indicates consistency data is clustered closer together. You can even say grouped, right? Average distance of each point is closer to the mean. Curve will be steeper you can say basically the same thing from Winnipeg's perspective. For Winnipeg, you're writing this down, so I'm going to slow down there a bit. Just write this down first. So for Winnipeg, you basically flip what you said about Toronto, right? If I asked you to come from Winnipeg's perspective, a lower mean indicates colder temperatures on average. The range and standard deviation are higher or greater which indicates inconsistency data is spread out or dispersed average distance of each point is further from mean. I'm just going to use X bar there for mean. And last, curve will be flatter Okay. What I want you to do, page 6 and 7, let me just check. If you're writing this down, I'm coming back. Pages 6 to 8, homework. You're practicing this exact same skill. More numbers, but other than that, same thing. It's going to give you a bit of a heads up in terms of what to expect, what should you watch out for. So for example, page 6, this is just a one set, right? You can put this all into L1 and guide you through it. Are there any outliers? Can you see outliers? And then put this on the number line, which I already provided. You just need to label, put arrowheads, all that stuff. And then pages 7 to 8, it's a bit more. You're talking batteries, 2 brands of batteries and their lifespans, how long they lasted. And so I basically want you to collect that information here, the mean, median, standard deviation, and so forth. But it's very important that you know how to create line plots for each of them and describe what does that information tell me. If I look, let's say you get called in by companies like, hey, we have all this data here. What does that tell you, right? It's like, oh, brand X has a greater mean, so that means that lifespan is better, right? It lasts longer. I'm just making this up. I don't know what the answer actually is. I would have to look at my key. A standard deviation. If brand X has a greater standard deviation than brand Y, then you're saying, well, brand X varies a lot. You could get a battery lasts a long time, or you can get a dud, right? That was made on Friday at 5 p.m., right? Dies on you after 1 year. So when you go to Amazon, if you see those ratings, right? 5 stars, 2 stars, 5 stars, I'm like, I'm staying away from it. Unless it's very cheap, then I might still go for it, right? So I make that call based on the price. But things like that, I want you to apply that. Hence the name of the course, right? Applied math.